The purpose of this video is to show you how to find the formula for the nth term of a geometric sequence. If you're asked this, it may not be obvious that it's a geometric sequence. You can still go through, I recommend going through the motions to see if it's linear first. And that would be to just find the first difference. So this one's adding 10, and then this one's adding 30, and then it would be adding 90. Okay, so clearly it's not linear because the first difference is not constant. You can try quadratic. And so 10 to 30 is plus 20, and 30 to 90 is plus 60. So since the second difference is not constant, it is not quadratic. Okay, this one is fairly obvious that you're not adding or subtracting, but you're multiplying. But just in case it's not, it's no problem just go through these steps anyway. But if you look, I think I'll just probably go along the top here. 5 to 15, you're multiplying by 3. 15 to 45 times 3, and then times 3. If it's not obvious, and you're not sure what it would be, like what times this gives you the next one, you can always divide. So 15 divided by 5 is 3, 45 divided by 5 is 3, and 135 divided by 3 is 45. So if you have decimals or something that you're not familiar with, then you can just divide and see if there's a common ratio. It's actually what it's going to be called. And since the common ratio is constant, then you know that this is a geometric sequence. Okay, and the formula for the nth term of a geometric sequence is un equals a times r to the n minus 1. And if you're a GCSE student, you have to know this. So a stands for the first term in the sequence, and r stands for the common ratio. So in this case, a is 5, and the common ratio is times 3. So if it went from like 15 to 5 to 5/3, then you would make this a fraction. This would be like 1/3. But we're making things bigger, so it's going to be multiplied by 3. And I'm going to use the multiplication sign there because 5 and 3 next to each other can be kind of confusing. And to the n minus 1. So there's a formula. And this will generate any number in that sequence. So we can try it out. If you wanted, for example, the third term in the sequence, we know the answer should be 45. And so this is the first, that's the second, and that's the third. So we should be able to plug a 3 into this formula and get out a 45. So let's try it out. So 3 is equal to 5 times 3 to the 3 minus 1. So the third term in this sequence should be equal to 5 times 3 raised to the 3 minus 1 power. So U3 equals, I can't do 5 times 3. This is not a lesson on order of operations, but I do, they're important and you should know them in order to do this problem. So it's 3 squared and 5 times 9. So the third term in the sequence should be 45, and sure enough it is.